Hello, I welcome you in this recording of steam turbine, which is in our chapter 2, 2.8. In this steam turbine, we will discuss about its types, classifications, and its advantages and disadvantages, its all construction details and various parts, and what are the mechanism, how we get work output from the turbine. First of all, we should know what is a turbine. You know, turbine is a prime mover, steam prime mover, which converts thermal energy first in its nozzle to kinetic energy, and then the kinetic energy converted into mechanical energy, and that mechanical energy converts that mechanical energy utilized by the turbine shaft, which produces the output, the torque. That torque is transmitted to the generator shaft. In the generator shaft, you know, the armature are present, then the rotation of this armature will produce electromotive force, that is electricity, which is, it is the output of the power station, any thermal power station. So, that in details we will cover today about the steam turbine. Myself, you know, myself G. Ghadai, Senior Lecturer Mechanical, Bose, Cuttack. In the last class, we have discussed about the Rankine cycles, that is the thermodynamic cycles of the thermal power plant. And in the thermal power plant, you know, the steam turbine, it is the main component of the Rankine cycle. So, it is a sort of prime movers used in steam turbine. Now, I will draw the Rankine cycle, the TS diagram. Here the 1-2 process is your process, thermodynamic process in the steam turbine. 2-3 is the heat rejection in condenser, and 3-4 is the heat addition in boiler. It is the 4 components in the thermal power station, and this 1-2 process takes place in the steam turbine. So, now how heat to convert energy we will see. The steam turbine convert heat to work energy, that means low grade energy to high grade energy. Heat is a low grade energy and work is a high grade energy. And about the construction, the steam turbine consists of fixed blades and moving blades. Fixed blades means it is works like your nozzles, and where the pressure drops and we get the heat energy converted into kinetic energy in the fixed blades, and moving blades. In the moving blades, your kinetic energy converted into mechanical energy, that is work output. We get the work output in the moving blades. And the fixed blades and moving blades in a strong casing fixed blades, that means they are located in a strong casing. are also called nozzle or diaphragm or guide blades. These are the different names of the fixed blades. You can call as nozzle or diaphragm or guide blades, and are attached with the casing of the turbine. You remember, the fixed blades are attached with the casing of the turbine. And again, function of the nozzle is to convert pressure energy or thermal energy or enthalpy into a high velocity jet. That means, the fixed blade in the turbine, its work is to convert the heat energy or the enthalpy into high velocity jet, that is the kinetic energy. The moving blades, they are called as bucket or rotor blades. The moving blades or bucket blades or rotor blades are attached with rotor. So, rotor means the shaft which rotates inside the casing, and in the shaft these blades are fixed, and here the steam flows at high velocity across the blade, and that we get the mechanical work. So, its mathematical treatment I will discuss later on. Therefore, the total overall function of the turbine is to convert pressure energy or energy associated with the steam into mechanical work. So, this is the overall function of the steam turbine, which converts pressure energy or energy associated with the steam into mechanical work, because the pressure energy you get from the boiler, which contains heat, enthalpy. So, now the construction, I will make a line diagram of steam turbine. এটা কিন্তু রিমুভ করিবা পড়েব না পড়ান্তা কেମିତି. Now we will draw the line diagram of the steam turbine, and then we will be very much clear how the steam turbine works. So, this is the line diagram of the steam turbine. So, this is diverging in section. That means, your volume expansion takes place. That means, the pressure from high pressure P1 it reduced to P2. That means boiler pressure is P1 and the condenser pressure is P2. So, here therefore, it is a diverging type. Here the volume of the steam increases and the pressure decreases. So, this is the symbol of the any turbine. It may be gas turbine, steam turbine, water turbine. So, this is the symbol. So, here the fixed blade, it is attached to the casing. This is your casing, and moving blade is attached to the rotor. This is your rotor or shaft, and the output of the turbine is utilized by the generator, which will produce electricity, and it is connected to the load, any type of load, factory load or any consumer load, it is utilized. So, this is the arrangement of the rotor and fixed blades in the turbine. You can also remember the function of the nozzle is to convert pressure energy. So, here how the nozzle works I will discuss. Now, come to the function of nozzle. This is a nozzle. Here section 1 and this is 2. If you apply the steady state energy equation, that is SSEE. This equation already we have utilized in the Rankine cycle. It is applicable to the open system. This nozzle is also a open system. Here the equation says H1 plus V1 square by 2 plus GZ1 plus Q is equal to H2 plus V2 square by 2 plus GZ2 plus W work output. You know H is the enthalpy, V is velocity and Z1 is the datum height, or it is a enthalpy, heat energy, this is kinetic energy, this is potential energy and a heat transfer. This is in the outlet, same property in the outlet. Okay, Maria. Now, we will simplify this. Here, your GZ1 is equal to GZ2 because it is a horizontal, and this approach velocity V1 is also negligible compared to outlet velocity. This approach velocity may be tends to 0. So, it is negligible. So, now the equation reduced to, and also in the nozzle there is no heat transfer, heat transfer it is 0. Work also 0, work transfer, no work transfer in nozzle. So, what happens in nozzle? Now, H1 is equal to H2 plus V2 square by 2. So, this output velocity of the nozzle is the inlet velocity to the moving blade or turbine. So, V2 square will be H1 minus H2 into 2 root over this is the output velocity of the nozzle, which is the inlet velocity of the turbine. If we simplify this, and V2 will be 44.72 into this change in enthalpy delta H, where enthalpy in kilojoule per kg, the unit of enthalpy in kilojoule per kg. So, this will be the output velocity of the fixed blade or nozzle, and this velocity is the strikes the moving blade. So that we get the work output in the turbine. So, for this case I want to draw a velocity diagram, which will help you in how the turbine works. So, say this is the one moving blade, which is a curve like this is your inlet velocity diagram, inlet velocity triangle. This triangle consists of 3 vectors. One is the relative velocity Vr1 in inlet, and this is the blade velocity u, and this is the velocity of the steam coming from the nozzle V1. And this relative velocity always tangential to the blade surface, because there will be no shock. That means, the shockless entry of the steam should be there. So, therefore, the relative velocity strikes tangentially. So, this is the steam coming out from the blade after doing work. After doing work, the steam coming out in the Vr2. This is the u remains same. The blade is so that the blade height is very small. So, linear velocity of the blade is same. So, this is V2. So, here R stands for relative velocity, and 1 stands for inlet, 2 stands for outlet. So, if you will see the horizontal component of this V1 is called as VW1, wheel velocity, that is called wheel velocity, and the vertical component of this V1 is your flow velocity VF1, this is VW1. Similarly, here this vertical component and horizontal component, this is VF2 and this is VW2. This horizontal component of this velocity, steam velocity, actually helps in doing work, and a VF only the flow, it helps in flow of the steam to the through the turbines, turbine blades. That means it glides from one blade to another. Just this is one blade. I have shown one blade. In the rotor, we will see number of blades. Number of blades. There are axially. So, this steam coming from one fixed blade to another empty, lastly you will be get the output. So, here the wheel component, again the angles, this is your absolute angle alpha 1, this is the blade angle beta 1, similarly this is beta 2, blade angle, and this is alpha 2. So, this is the velocity triangle in the blade, in the moving blade. So, you remember again I am writing the values. V is the steam velocity, in meter per second, U is the blade velocity, and beta is the blade angle, and alpha is the flow angle, steam flow angle or nozzle angle or angle of the fixed blade. So, from this you will get a how the work is done. You know, you have to remember that the steam coming out of the nozzles at velocity V1 falls with relative velocity Vr1 on the blade, which moves with linear velocity, which I have already told, that the steam coming out of the nozzles at velocity V1 with the relative velocity Vr1, it falls in the blade, because blade is also moving simultaneously. So, the relative velocity only touch the tip of the blade, and the blade is moving in velocity u, blade velocity, this is the u. The direction of a Vr1 must match with the blade surface to allow shockless entry. Remember, the direction of Vr1 must such that the blade surface is allow shockless entry. Number 3 is the component of the steam velocity in the direction of motion of the blade is called wheel component. ये जो V1 जो component है, it is horizontal and the blade velocity also horizontal. So, this component Vw1 is responsible for doing work, that is known as wheel component. Vw1 is known as wheel component, wheel velocity, and this is called as flow velocity, Vf1, flow. The final force which you get, you know, the change in momentum, initial momentum minus final momentum will give the force. Suppose the mass is 1, then your suppose mv w1 minus mv w2, it is a change in momentum in the direction of u. Here it is Vw2 is opposite in direction, then it will be change. If it is change, that means it is minus, minus into minus. So, difference will be plus. So, then this is the force, or you can say your work done will be force into velocity u. So, this is the W work done. So, finally, it is will be m Vw1 plus Vw2 into u. So, this is the work output of the turbine. Now, to get the in terms of torque, T will be, this is the your work output. Another equation is T torque is equal to Vw1 R1 minus Vw2 R2. So, here R1 R2 is the radius of the two blades. R are known as radius of blade, curved blade. In inlet is R1, in outlet is R2. So, this is the one. Another mathematical formula. Last one is this is a general equation for turbo machines. General equation of all turbo machines. That means where only rotational motion takes place, no reciprocating. So, your general formula will derive from that velocity triangle, but it is not in your syllabus, but you should know this Euler equation this is centrifugal force. This is your reaction component. And this is your impulse, change in kinetic energy. This is change in kinetic energy. So, these three parts is the another form of this same equation V w plus B w2 into u. If we will take the help of velocity triangle, we will get this equation. Now, for axial turbine, this equation can be modified to different form. For axial turbine, your alpha 2 is 90 degree, remember. And in case of reaction turbine, you know in the reaction turbine, pressure as well as kinetic energy changes takes place. They both reduces. So, here the inlet pressure of the blade is equal to not is equal to outlet pressure in case of reaction turbine. In reaction turbine, the pressure drops in the reaction turbine along with velocity, and in the impulse turbine, so these are the different types of steam turbine, reaction turbine, impulse turbine. Here pressures remain same, P1 is equal to P2 and VR1 is equal to VR2. So, that means for impulse turbine this part will be 0. Again, is the radial inward and radial outward. U1 is equal to U2 greater than U2, then it is the condition for inward flow, inward radial flow. And if U2 is greater than 1, reverse. If U2 is greater than U1, then it is outward flow, outward radial flow turbine. So, now, by this mathematical analysis, so you can know the different types of turbines and how the velocity triangle will draw. In the next, I would page.